Experimental building is our entry-level course taught primarily to second and third graders. So things to keep in mind are that no programming is taught in this class. It is only building with Lego, which might be good or bad news depending on who you are. Next thing is that for many students, it is their first exposure to Lego building of any kind. So what that means is that sometimes things that seem kind of obvious need to be spelled out for them. And lastly, it is designed to be a stepping stone for more advanced classes. So in theory, they would move on after this class to programming fundamentals, which would teach them how to program in LEGO Mindstorms, and finally to creative automation, where they would combine those two skills, building and programming, to build and then code their own bots. And below here you can see the proficiency and mastery goals for this class, which is taken straight from the curriculum summary, which again you guys should read. Okay, so in terms of what you guys need to know, over here on the right hand side you can see the ports for the LEGO Mindstorms controller. So there are ports 1, 2, 3, 4 on one side and A, B, C, D on the other side. So the lettered ports are for motors and servo motors, and the numbered ports are meant for sensors. So again, experimental building mostly has to do with Lego building. This is one of those things that might seem obvious, but in order for two pieces of Lego to be connected together, you need to use two pegs. In the tower building activity, a lot of students only use one peg to connect each beam, and that results in a really floppy tower, which is what we don't want. So that is something that you should definitely tell your students if they have trouble with. Ports we've already gone over, and controller navigation we went over in the introduction if you haven't seen it already. The other topic that this course deals with a lot is mechanics, and one of the activities related to mechanics is the rubber band car. What you should be telling your students is that the rubber band cars can be made to travel farther by using larger wheels, and they can also be made to travel farther by increasing the length between the rubber band and the drive wheel. So during the course we actually repeat the rubber band car activity twice, and the second time we do it we use gears, which makes things a lot more interesting. So with two gears, the driven gear will always turn the opposite direction of the driver gear. So a lot of the kids put together their rubber band car with gears, but it ends up going the opposite direction. So you can tell them that's why. The next thing is that having a large gear driving a small one will result in a higher speed but a lower torque, and having a small gear drive a large one results in a lower speed but higher torque. Often what happens is that the kids modify their car to have the biggest gear ratio possible so that they can go the fastest, but what ends up happening is that when they run it, the wheels end up skidding on the ground because there's not enough torque to propel the vehicle forward. So if that happens, you can tell them this, and you can explain to them that they probably want to have a smaller driver gear. Finally, on the last day of class, each group of students makes their own sumo robot, and they participate in a tournament where whichever bot gets pushed out of a ring first loses. If the teachers are interested, it's pretty fun to make your own sumo bot and run it against the students, especially if there aren't a lot of kids in the class. But as teachers, you guys should be encouraging the kids to build their own robot, because a lot of the time what happens is that they don't have any ideas and they just resort to building the starter bot from the first day. We don't want that to happen, obviously, so you should be telling them that they want something that has a low center of mass, so it should be a pretty squat robot. They also want it to have a lot of weight so that it is hard to push around. Some ideas to start them off with would be a robot that uses tracks, and another good one is a bot that uses a gear ratio of some kind. Whether that means making the bot go really fast at the opponent or slow but with a lot of force.